A simple way to think about module prepend is to consider it as an alternative to the module include method that places the supplied modules in a slightly different place in the chain of ancestors. Up front, I should note that if you're not already familiar with modules and inclusion, then this video probably isn't for you and most likely will confuse. But with that disclaimer in mind, let's take a simple contrived module inclusion example. So here we have a module bar with a method called myMethod, a class foo that includes the bar module, and then we create an instance of the foo class and call myMethod. We get 10. Very simple. But now let's change include to being prepend and see what happens this time. Same result, kind of boring. So let's move on to a similarly contrived example to see what the difference is between include and prepend. So now we have a myMethod already defined in the foo class. We can see that here. And it returns something different to the version that is inside the module, which is here. So let's try with include and prepend again and see what happens this time. So when we run this time, we just get the inside the class version. Using include, the methods in the module don't override those already in place in the class. But if we use prepend, then they do, and we get the module one. So, now to make things interesting, let's introduce super. Super is a special method invocation keyword in Ruby that heads up the inheritance tree, essentially, of classes and modules and invokes a method with the same name as the current method in a superclass of the current class. So just think of it as, heading up that tree, and it will go and find the next method with the same name up the tree. So when we do an include, the module gets introduced at a higher level in the chain than the class it's being included into. So that's why if we have myMethod defined at the class level, like we do here, and the module version doesn't really get a look in. But if we use super from here, then we can. So this will actually change how things work, and we'll change this back to include. So before this would have said inside the class, but now it will stay as inside the module, because this method is being run. It's going past this section here, which does nothing, goes super, and then goes up the chain to the module that was included. Excellent. Now, prepend does the opposite. So if we change this over to prepend, and we get rid of super here, now what will happen is this module one will be run first instead. So what we can do from here is we can do super, and if you're following along, hopefully you'll figure out that if we call myMethod, because of the prepend, it will go to the module version first, but then super will go up the tree back into the class, and we'll get inside the class come back, as we do. So that's prepend at the simplest, most contrived example. But it's perhaps best if we look at a diagram showing the situation in both cases. Now, bear in mind that this isn't entirely accurate in terms of representing all the internal structures and singleton classes and stuff that are present, but it is a very simple look at what's happening. So you can see the difference here between what's happening when we do prepend and include in terms of where it's putting it in that chain. So this is all very simple, but let's try something a bit more useful as a larger example. Now, there are many examples that you can use for doing module prepending, and many that you'll find online will base themselves around the old Rails technique of using alias method chain. That would allow you to get module prepend style functionality on a method by method basis by renaming an existing method, then defining a new method which would call the old rename method. And as there are so many of these examples, I'm not going to provide such a demonstration. You can Google for prepend and alias method chain to find those. There are tons out there. Instead, I'm going to demonstrate how module prepend lets you essentially sit in the way of a class's existing methods as a form of protection. So you could accomplish this with alias method chain or your own metaprogramming and redefinition of methods, but in Ruby 2.0 it's a lot easier with module prepend. Here we have quite a simple user class with name and admin attributes and an initializer that lets us set their values. All very simple stuff. I create two users, a normal one called Fred and an admin called Jill. I then set normal's admin attribute to true, and it just works. So we'll just double check that. Yep, all works fine. Now, let's prepend the user protection module without actually seeing what it does. So I've kept it all hidden, the code up here. Let's bring it in and see what happens. So now we run this and we get an exception saying you do not have permissions to set this attribute. So something in the user protection module is redefining the admin equals method at the very least, checking to see if something is happening, if perhaps the person adjusting that object is an admin or not, and then only allowing the underlying setter method to be called if that is true. So let's actually look at the code. In here we have an operator accessor and then redefined versions of the name and admin setters. So that's the name equals and the admin equals methods. Each looks for an operator, and if there is one, it checks to see whether it's an admin. If it is, then it will pass up the chain. So this will go to the normal name equals and admin equals methods. And if it doesn't, then it will raise an exception. Let's make some changes here. How can we get this to work? What we can do is we can say normal.operator equals admin. And what this will then do is set the operator to the admin, and because the admin's admin attribute is true, it will allow us to pass through and make the change. So if I run this code, we can now see we get true. But if I change the operator to normal, then bam, we get the exception again. As I said earlier, this is a contrived example, but these sorts of applications could be very useful in real-world code in situations where perhaps mass assignment is occurring, for example. If an authorization system of some sort can be quickly added to any existing class using the prepend method, that is very useful, and now it is easy to do just that. Two minor things to finish. If you've used modules a lot, you'll be aware of the included method, which you can define upon a module and which is then automatically called by the Ruby interpreter when that module is included into something else. Now, the benefit of this is that you could then dynamically do various things with the target class or module, such as add extra class methods directly onto it with extend, for example. That's a common thing that you tend to see in large-scale Ruby development. Now, prepend gets us a similar benefit in the shape of the prepended module method, as shown in this code. So here, very simple example, we do a prepend, but when this prepend is run, this behind the scenes is also run. So if I run this code, it will come up and say, I've been prepended onto foo. So this works in much the same way as the old included method, and I can show you how that one works. There we go. We can also revisit a rather heavily edited version of our user protection example from earlier to see why prepended can be useful. We've replaced the whole operator thing with a simple flag that determines if an object is editable or not. So that's what you'll see here with this disable edits and enable edits in the module. All that does is it just changes this instance variable called editable to true or false. But then what we do is instead of having methods like name equals and admin equals and doing all of that by hand, we don't have them anymore. It's all done dynamically instead. And we do that in this prepended method. So when the module is prepended to the class, it comes into here and then we dynamically look up all of the different setter methods, which is what this section is for, using the instance methods method. And then for each, we define a new method within this module, which is being prepended, and we check to see the editable flag. If it's okay, then we pass it up the chain using super. Otherwise, we raise the exception. So in this way, this code will run as is, but if I go disable edits, then we get the exception. Care is required with this sort of approach, however, since if we use the edit protection module with multiple classes, those dynamically created setter methods would exist in all cases across all the various places it's been prepended. So in this example, that wouldn't matter because we want all attribute setters to be protected, but that might not be true everywhere. So this is why testing is very important. Minor thing number 2. Module prepend calls the prepend features method upon the modules it is passed. So prepend features then actually does the heavy lifting of doing the prepending, if you will. So here is a very basic example. So this time we have the class first and then the module instead of the other way around. And instead of prepending from the class, we use prepend features here on line 16 from the module. It works in exactly the same way, except we would have done things from the opposite direction in getting the module to prepend itself to a class. This also means we can more easily dynamically prepend modules. So I've put a little basic example in here. If I get rid of this, and then I get rid of this prepend features here, now if we run this code, we get the inside the class coming up. But I can then dynamically enhance my foo class. So this gets called, it prepends the feature on, and I've actually just told the module to add itself into the foo using prepend. And that's it, a basic walkthrough of module prepend. Your job is now to find clever uses for these features and discover ways in which they will make our code and libraries a lot easier to read and use. Good luck.